Good morning, class. This is Teacher Mary, and today we are going to discuss L'Hopital's rule and indeterminate forms. But before we start, let me read to you our learning objectives. So, at the end of this lesson, students shall be able to first recognize when to apply L'Hopital's rule. Second, identify indeterminate forms produced by quotients, products, subtractions, and powers. And last, third, apply L'Hopital's rule in each case. So just a quick review, back in the chapter on limits, we saw methods for dealing with the following limits. As we can observe here, in the first limit, if we plugged in x is equal to 4, we would get 0 over 0. And in the second limit, if we plugged in infinity, we would get infinity over negative infinity. So recall that as x goes to infinity, a polynomial will behave in the same fashion that its largest power behaves. So both of these are so-called indeterminate forms. Now, what are the indeterminate forms? So for us to easily memorize what are indeterminate forms, we can classify them into three. So first, we have infinity over infinity and 0 over 0. Second, we have 0 times positive negative infinity and infinity minus infinity. And last, we have 0 to the power of 0, 1 to the power of infinity, and infinity to the power of 0. But for this session, we will focus on the first category. In the case of 0 over 0, we typically think of a fraction that has a numerator of 0 as being 0. However, we also tend to think of fractions in which the denominator is going to 0, in the limit as infinity or might not exist at all. In the case of infinity over infinity, we have similar set of problems. If the numerator of a fraction is going to infinity, we tend to think of the whole fraction going to infinity as well. Also, if the denominator is going to infinity in the limit, we tend to think of the fraction as going to 0. As already pointed out, we do know how to deal with some kinds of indeterminate forms already. For the two limits I have shown you, we work them as follows. So here in the first case, we simply factored, cancelled, and took the limit. And in the second case, we factored out an x squared from both the numerator and the denominator and took the limit. Notice as well that none of the competing interests or rules in these cases won out. That is often the case. So we can deal with some of this. However, what about the following two limits? So the first limit is a 0 over 0 indeterminate form, but we can't factor this one. The second is an infinity over infinity indeterminate form, but we can just factor an x squared out of the numerator. This is where the subject of this class comes into play, the L'Hopital's rule. Suppose that we have one of the following cases. The limit of f of x over g of x as x approaches to a is equal to 0 over 0, or the limit of f of x over g of x as x approaches to a is equal to positive negative infinity over positive negative infinity, where a can be any real number, infinity, or negative infinity. In these cases, we have the limit of the function as x approaches to a that is equal to the limit of the derivative of the numerator and denominator as x approaches to a. So, L'Hopital's rule tells us that if we have an indeterminate form 0 over 0 or infinity over infinity, all we need to do is differentiate the numerator and differentiate the denominator and then take the limit. Now, let us work with some examples. For our first example, we have the limit of sine x over x as x approaches to 0. We have already established that this is a 0 over 0 indeterminate form, so let's just apply L'Hopital's rule. So the derivative of our numerator is cosine x and the derivative of our denominator is 1. When we plug in our value of x, which is 0, we get 1 over 1, and therefore the limit of sine x over x as x approaches to 0 when L'Hopital's rule is applied is equal to 1. So for our second example, we have the limit of 5t to the power of 4 minus 4t squared minus 1 all over 10 minus t minus 9t cubed as t approaches to 1. In this case, we also have a 0 over 0 indeterminate form. And if we were really good at factoring, we could factor the numerator and denominator, simplify, and take the limit. However, that's going to be more work than just using L'Hopital's rule. So, we apply L'Hopital's rule in this example. We have to derive our numerator and denominator. So, we have now 20t cubed minus 8t all over negative 1 minus 27t squared. So, we apply the limit, that is t is equal to 1. And we have 20 minus 8 all over negative 1 minus 27. So, we simplify our answer and then we get negative 3 over 7. Let's move on to our third example. We have the limit of e to the power of x all over x squared as x approaches to infinity. So this was the other limit that we started off looking at, and we know that it's the indeterminate form infinity over infinity. So let's apply L'Hopital's rule. So we have here our limit e to the power of x all over 2x. So we derived our numerator and our denominator. Now we have a small problem. This new limit is also a infinity over infinity indeterminate form. So what we're gonna do? However, it's not really a problem. We know how to deal with these kinds of limits. Just apply L'Hopital's rule once again. So, when we apply the L'Hopital's rule, we get the limit of e to the power of x all over 2 as x approaches to infinity. So, the result is infinity. Sometimes, we will need to apply L'Hopital's rule more than once. Now, look at the example I have here. Note that we really do need to do the right-hand limit here. We know that the natural logarithm is only defined for positive x, and so this is the only limit that makes any sense. Now, in the limit, we get the indeterminate form 0 times negative infinity. L'Hopital's rule won't work on products. It only works on quotients. However, we can turn this into a fraction if we rewrite things a little. So, we have our limit of x ln x as x approaches to 0. So, we rewrite that we have ln x all over 1 over x. The function is just the same, just rewritten. And the limit is now in the form of negative infinity over infinity. And we can now use L'Hopital's rule. So we have already the function of 1 over x all over negative 1 over x squared. So, we can now evaluate that one. So since we have the same numerator and denominator, it only differs with the power, we can cancel that out and we remain with negative x. So, when we take the limit, which is 0, the answer of the limit x ln x as x approaches to 0 is 0. Now, it's your turn to do some exercises. Get a long bond paper and then evaluate the following limit. After you answer that, take a photo of it, scan, and submit it in the Google Drive link below in PDF format for your assessment today. And here is your assignment. We will check that on our next meeting. So I hope you have learned something today. Goodbye class and see you next meeting.